Yes, good morning. Hello, everybody. First of all, I have a meeting on Thursday, so this will our last lecture today. So I have to do it today a bit faster. And then, of course, I want to recommend that maybe if you have time, you can join the talk of Lukas Nö from the Council of Economic Experts of Germany, and also here below there, of course, you can join via Zoom because also Lukas Nö is also joining via Zoom from Wiesbaden this day. Okay, then where were we? We are talking about the neoclassical theory, and then in neoclassical theory we relax the last assumption and we assume that from now on prices are totally flexible, and from this on then we thought about the market of capital markets, and especially we looked at the labor market, where we relaxed now the assumption that especially in the labor market we would have wage rigidities, and this means that in the labor market we deduced from profit maximization the labor market, the profit maximization, of course, the labor market demand, and from consumption spare time maximization we derived the supply function at the labor market, and then with the process of totally flexible wages we obtain the labor market equilibrium. And then we argued that within our economy mainly our labor market determines output as the most important market. In general, of course, we also look at capital markets, but in our class here, then we mainly focus on the labor market, as you will see in a minute when we are looking then at the general equilibrium. Well, and if we look simultaneously at all these markets, then there is the very famous law of Walras, Leon Walras, economist, professor in Geneva in the 19th century. And so to speak, he was the first one who looked from a theoretical perspective at general equilibrium. And then he found the following law, that if we look simultaneously at many markets where we are exchanging our goods and services, and all these markets are interconnected, then he found that if we look, for example, simultaneously at 4 markets interconnected, that then when 3 markets are in equilibrium, then by law the last market, the 4th market, has also to be in equilibrium. And this is totally comparable to our circular flow, which we had a look in the beginning of our lecture. There also we looked at the different sectors, and then we made the assumption that the inflows and outflows at every single sector has to be the same. And then if you have made the calculation in the right way, then of course you only have to calculate these assumptions for n-1 sectors, and then of course, also the last sector. There you have, by definition or by law, also the equation of inflows and outflows. And therefore, since we, so to speak, now look at capital markets and labor markets, determine the output, or afterwards we mainly focus at the labor market, then we do not have to ask if the goods market is in equilibrium, because by definition or by Walras law, this market has also to be in equilibrium. So then, from equilibrium of all other markets due to totally flexible prices, we obtain that commodity markets are also in equilibrium. YS and YD, P star and Y star. Well, and what kind of view is behind all this neoclassical argumentation? And this is the then so-called Say's law. Say is also an economist, a philosopher. I think mainly at first he studied law, also in the 19th century. And he formulated that this view that more or less our economy is determined by the supply side. So his argumentation was, well, once we start production of any good or service, within this production process, remember when we looked at the different approaches to calculate GDP, there we looked at the production view, then income view, and then we looked at the division on labor as input factor and capital as input factor. And there we argued that, of course, some part of our income in our economy comes from capital income and comes from labor income. And Say argued, well, this is just how our economy works. We start production, then we earn our wages, and we earn interest or the yield from our capital investment. And this is, so to speak, the starting point. Then we have income, and with this income, we again demand new goods and services. So the totally opposite argumentation compared to the Keynesian argumentation. Because in the Keynesian argumentation, we said from our household side, we think, well, a new bicycle would be nice. And since we say that a new bicycle would be nice, then the producer starts to produce. And now we argue the other way around. We say, because why we are producing, we have income, and then we have our demand. And then also this cycle starts, that we have our wage and our capital income, and these factor incomes promote then our demand, and together with totally flexible prices, all markets come to an equilibrium. And also we can ask, where does this view come from? And since this is in the 19th century, what time did we have in the 19th century in Europe? How do we call this time? Starting a bit earlier in UK, and then also in France and in Germany. Yes, great. So this was the time of industrial revolution. And if we think of this time of industrial revolution, we had more or less every day new inventions, new innovations. Because in this time, we do not have to think every day about what can I eat the next morning. In this time, it started that we came to the division of labor, that everyone specializes to his own abilities. This was the switch from the economy to be mainly focusing on the agricultural sector, switching to an industrial sector. So within this time, we had all these new products, so to speak, the modern interpretation of consumption more or less started in this time. That we just can think about not only spending 90% of our income for food and for housing. And here then it started that we can also buy other products. And from this background came then, of course, such a view. This was highly relevant in these times. But times are changing, and therefore I present you not only the neoclassical view, but also the directly opposite view of the Keynesian theory. And after this lecture, hopefully you can think by yourself what you think is, from your point of view, the best one. But you have seen everything, hopefully. Okay. And then, since we say that due to totally flexible prices and especially totally flexible wages, we have here our labor market, and here we have equilibrium amount of workers. And of course, this number of workers does not have to coincide with the number of people in a society which can work. And because of this, that still there are some people unemployed, then we say there exists something like a natural unemployment. For industrial countries, estimations say just so in between 3 to 5%. And these are then all the people which do not want to work for this wage. And remember the magic square. There also we argued that in Germany, we argue that full employment is around a number of 1 million or 1.5 million to be unemployed. Okay, and then for the end of this lecture, we want to have a look on the general equilibrium, and this will be also called the neoclassical synthesis, because within this model we also feed in especially our demand curve in our in our economy coming from the ASAD model. Remember, there we also flexibilized our prices. So this is a so-called four-quadrant diagram. And what do we see here? Well, if we look here at the down left quadrant, then we have here labor, and here we have real wages. So this is the labor market. And for this labor market, we just put in our supply and demand curve for labor depending on real wages. Well, and now we have to see that we draw labor downwards and real wages to the left. So this means that labor supply will go downwards, starting from the upper right to down left, okay? This will be labor supply. And of course, labor demand for high wages, a point here, the enterprises will demand only few amount of labor. And then they will increase their demand if real wages are decreasing. So this is labor demand. And then we argued that mainly labor demand determines our production. If we would want to look simultaneously on the capital market, then more or less we had to draw a three-dimensional diagram with just the capital market moving, so to speak, inside our slide. But here we have now our equilibrium amount of labor, determined from the labor market due to totally flexible prices. So then we have here labor, and to the left we have output. So which kind of dependence do we have between output and labor? Well, sorry, I deleted this in these slides. Then my question, what kind of function determines for us in the neoclassical view the dependence between production and labor, output and labor? Well, now I almost already gave the answer. Well, if you just look, I think about 10 slides before, there we had the neoclassical production function. And this was output and the input factors, and there we assumed that we have this right banding function, and this meant positive and decreasing marginal productivity. Well, and this determines for us, this production function, of course, the dependence between our labor input and output. Well, and if we draw this right banding function here with labor to the right and output upwards, then you just have to move this diagram 90 degrees to the right. Okay? If you flip this diagram to the right 90 degrees, then you have to the right y and downwards L. And then, of course, you also have to move your function 90 degrees to the right. So our production function then looks like this. So this is then production. Well, and then, since we mainly focus on the labor market, we have here our production. Well, and now remember our long run ASAD model. There then we argued that in the long run only the framework of our economy determines what we can produce. So this means from labor market and the neoclassical production function we obtain in the price quantity diagram P and output prices, not that long because I need some space, that this is our supply function. Well, and then more or less from our ISLM model, I and Y, ISLM, when we flexibilized within here, M over P equals L of I Y with flexible prices, we obtained the AD curve, or in our diagram we will call it then YD with negative dependence on prices. So from IS, LM, flexibilizing here in our LM curve, the prices we obtained, if you have a look in the former slides, our demand curve. And therefore we call this the neoclassical synthesis. So from this labor market we obtain our determined production and supply in our economy, And from the Keynesian approach, at first adding the money market with flexible interest rates, and then with flexible prices in the LM curve for real money amount, we obtained the demand curve. We have now a demand and a supply curve in the price quantity diagram, and this equilibrium then determines in our model the price level. So this is then equilibrium price level. Well, and then, so this is then the commodity. Market. And what do we have in the end? Well, we have here upwards our price, and here we have real wages, and real wages are defined as nominal wages divided by the price level. So if we look at this, and let's explain this down here, then we have real wages is a function of price level, okay? Because it's just defined as nominal wage W over P. So this I can write then as W times 1 over P. And if we think just for nominal wages as some number, then we can think that this is more or less a function f of x is maybe 2 times 1 over x. Nominal wages think of we just any number. And what kind of function or how does this function looks like? If I plot f of x depending on x, if f of x is 2 times 1 over x. How does this function look like? How does 1 over x looks like? Okay? F of x equals 1 over x. Yeah? Yes. Yeah, definitely. So if I insert here a really large number, then I'm close to 0. And this does not depend on if there is a 1, 10, or 100. And if I insert here a very small number dividing by 0.0005, then I have a million. So a really large number here. And this is called a hyperbola. Thank you. So this just looks like this, and this is called a hyperbola. Well, and where do we find this hyperbola? Because this is just nothing else. Again, move now to the left by 90 degrees. Our diagram here, f of x, if we interpret f of x as w over p. W over p. Well, we have here the determination from labor market of equilibrium real wages, omega star. From the other side, we have equilibrium price level in our economy. So then these two are intersecting in one point, and through this point now our hyperbola has to move. So our hyperbola looks then like this. So our overall equilibrium then, of course, also determine us our equilibrium nominal wage. So how far outside we find our hyperbola. So if in comparison I ask for a function g of x is 2 over x, so this would be nominal wage equal 1, and this would be then nominal wage equal 2. If I compare these two functions, then in general, qualitatively, they look like the same. But here, every number is twice as large as this number. So g of x then has to look like this. And this would be f of x. So the higher the nominal wage is, the farther outside we find our hyperbola we have to draw here. We will see this in a minute when we are talking within our neoclassical synthesis model about fiscal and monetary policy. So this hyperbola defines then via P star and omega star the equilibrium nominal wage W star. So this function is then just omega equals W star determined by the other markets over P. And this is then fixed number determined by the other markets. Well, and now we are done. Take a deep breath. This is the end of our lecture, more or less, or almost the end. Now we want to discuss within this model what happens if we make fiscal and monetary policy, but this is then an overall equilibrium model, where we looked at every market simultaneously and we have totally flexible prices. So at the next slide, you find it in a better way. And now we want to discuss in this model fiscal policy. So plus delta G. What happens? Now you have to put all your knowledge together and you have to ask. You find it also here in my letters I put on these models. Now you have to identify where, so to speak, at the first point enters a change of government expenditure. And then we have to argue which function is then changing, and then we have to recalculate the overall equilibrium. Where do we find it? Well, do we find it in the supply function of labor? Consumption spare time decision. Does this one depend on government expenditure? Well, this is just your individual decision what you want to make with your money. So there's nothing. Labor demand, production side of our economy. Again, this is just the cost structure and our production function. Also, nothing happens. Also, we especially do not change with government expenditure the overall production technology in our society. Well, hopefully, if we go then in the practical view, we hope that government expenditure will change in the long run somehow our infrastructure or with investment in education or so. But if we think of the short-term effect, there will also no change in our production function. So then also, YS, there nothing happens. But where do we find something? Well, I put it in here. I have here the YG in the AD curve, aggregated demand. And where did this function come from? From IS LM with flexible prices in M over P. And in the ISLM model, what happened? Or what happens if we do fiscal policy? I, Y, IS, LM. What happens in this diagram if we increase government expenditure? Oh, there's somebody. Then what happens in the ISLM model? Does anything happen at the LM curve, at the money market? Just have a look into your slides. This was in the end when we talked about the ISLM theory. Well, delta G, where do we find this in the demand side model? Yeah. Yes, definitely, because we have here our YD equals C plus I plus G. So from the commodity market, from the Keynesian commodity market, if this goes up, then YD shifts up, and this means, as you mentioned it, that the IS curve has to move to the upper right. So we obtain IS prime moves to the right. And what does this upper right move of AS means for AD, the aggregated demand curve? Then you have to move on your slides. We also discussed fiscal policy in the ASAD model. Anybody? This was just the deduction of the AD curve from the ISLM model. This looked like this. Y IS LM, and then we put this down. So if this shifts upwards to IS bar, then this equilibrium point at commodity and money market at this price level P0, remember, here we have M over P equals L of IY. So this determines us or gives us a dependence of this level Y0 connected with some specific price level P0. And if we now only change government expenditures, so IS shifts upwards, then at this point of the argumentation, the price level has not changed. So then this price level is now connected with the new income level Y0 prime. And this we have to do for all price levels. Here we argue that AD with flexible prices then looked like this. So every point here has to move to the right. So we obtain then a shift to the right of the AD curve. And this we have to do here then, that we obtain a new demand curve depending on P, M, and now G plus delta G. And this is the only part in this neoclassical synthesis where something happens. So Here we do not have a change. Here we do not have a change, but here we have a new equilibrium price level, P star prime. And now we obtain a new intersection since the equilibrium real wages does not change, that we obtain now the intersection here. And then we have this new hyperbola determining now a new nominal wage level of y star prime. So in the end, only price level P star and nominal wage level V star moves up to P star prime and V star prime. So this is fiscal policy. And now comes, of course, monetary policy plus delta M. Let's take another color, green. What happens in this model and where does anything happen when we increase the nominal amount of money? Again, the argumentation. This is our private individual household decision, how much time I want to spend to work. So nothing happens. Also, in the profit maximization of the firm, nothing happens. Nothing happens to our general production function. So, YS, supply function, doesn't change. But here I have written down the dependence on nominal amount of money. So we have to go again into our ISLM model. What happens here in our ISLM model if we are doing monetary policy? Yep. Upwards? Really? Where does the LM curve comes from? In a minute, I just draw it. So here we have LM, L of I, Y, and M over P. Yeah. Yes. So here we have then M plus delta M over P. P in this argumentation does not change. So this moves to the right. And this means, since here we look at income to be a fixed number, that now the same income is connected now to a lower interest rate. So if we look at this point, for example, then this income number here is now connected not to this interest rate level, but to a lower interest rate level. And therefore, the LM curve has to shift to the lower right. Okay? Just have a look at this when you recapitulate this for the exam. So, plus delta M means that LM moves to the lower right. And what does this mean for AD? Well, again, we derived AD that some specific income is connected to this price level here. But now we have shifted LM to the right. Keep in mind, prices are still constant. So this point then is connected now to this new income level. Okay. So we obtain then again here a right shift of this specific point of our starting AD curve. And then you flexibilize in your mind prices. You have to do the same argumentation for P0, P1, P2, larger price level and lower price level. So again, you obtain a right shift of AD. And with this right shift, we go into our overall model. So we obtain again an upward shift of YD prime P G M plus delta M. Nothing else changes. So again, we obtain a new price level P prime. Real wage in equilibrium is still the same. We again obtain qualitatively the same new intersection point at now again a higher nominal wage level V star prime. So again, only the price level P star and the equilibrium nominal wages W star move up to P star prime and W star prime. So, and this is then the argumentation of our neoclassical economists who just say, well, please do not intervene via monetary policy and do not intervene. Well, this I can do here. Let's see if this works. No? I tried afterwards to change this color in red. So, please do not fiscal policy or monetary policy, because the only thing what happens is that all prices are adjusting upwards. And if you remember when we talked especially about inflation, there we said, well, of course, in our economy, prices can and they should change, but the price level in general should not always jump. because we really don't wish times like this with 10% inflation. And the argumentation from the neoclassical view is that if we intervene from the government side or from the institutional side, the central banks via monetary or fiscal policy, the only thing which you create is inflation. This we have here, and so, and well, and this is my normative point of view on economics, that I say, well, you always have to look at the times we have right now, which theory is the right one. I'm not a friend of an argumentation, well, always you have to adjust your economic policy decisions to a Keynesian view. So always push, push, push the economy. Even John Maynard Keynes didn't argue like this. He always said, well, within a crisis, it is a good idea to stabilize our economy. But think of the business cycle we talked about. John Maynard Keynes strongly argued that in, so to speak, good times, please cool down your economy. Do not think in good times, well, everything is working, then we go on and go on and go on. Well, you have, of course, as a policymaker, as a minister, or as a president, of course, you have also in good times an incentive to also push the economy. Because then maybe in the next poll you always will win. You also will win. But also within, if you, I would say, if you have a right view on Keynesian theory, then you also know that in the upward sloping business cycle, you should be not that progressive with your government expenditure decisions. So in general, as we have seen, especially in the last crises in the last 10, 15 years, we saw that Keynesian economic policy works. We can stabilize short-term work. For example, in Germany, the scrappage allowance in Germany, all this worked. And this worked like the Keynesian theory has proposed it. But also right now, inflation started to increase. And this is, I think, highly due to this change that also, of course, in the long run, prices will start to move due to the argumentation of the neoclassical view. Okay, well, let's do also some exercises. 20 minutes left. Maybe I have to take some more time. I know this is a hard cut, but as I said, I have a meeting on Thursday. So there's this. Step back now to the pure Keynesian commodity market. What do we have? We just argued when we talked about the neoclassical tendency, what happens with fiscal policy. We have to look where does happen in our theory anything by fiscal policy, and then we argued, well, it is just here, yd c plus I plus g, and we have c0 plus cy y plus I plus g. Let's put in these numbers, 30, 50, and 70, and 90% marginal propensity to consume. So we obtain 30 plus 0.9 times y plus 70 plus 30. Oh, 50, sorry, 50. Take the fixed numbers together, we obtain 150 times 0.9 times y. It is always a good idea, although I have it here in the end, support, but also for the exam, just have these diagrams in mind when you do calculations. So here we have yd and y. We are looking at the commodity market in equilibrium. So we start with all possible equilibria. This was the 45-degree line. These are all our possible equilibria, but we have yd with 150 times 0.9 times y. So this is just a straight line with the lower slope. Here you have slope equal to 1. Here you have slope of 0.9. So we are starting at 150 with a lower slope. So this is yd 150 plus 0.9 times y. And what we want to calculate is just the intersection here. So equilibrium means y equals yd. And then we have y equals 150 times 0.9 times y. Collect all terms with your variable y. So minus 0.9 times y is then 1 minus 0.9 times y equals 150. So y star equals 150 over 0.1 is 1,500. What do we have to change? So this is A and B. Let's take another color, green. Doubling government expenditure. What changes in our diagram and what changes in our calculation? Conceptually, this is the same we have done 5 minutes ago. Where does a doubling of government expenditure enters our model? Government expenditure is our variable G. Where do we find it? I know it's early today, but I think it's just here, or? And this G was 50. And if we are doubling our government expenditure, then what changes in our calculation? Doubling means not a 50, but yeah, 100, of course. So this 50 will just be 100. If this is 100, then this 150 will be 200. So this will be 200, this will be 200, this will be 200, and 200 over 0.1 is almost 2000, of course. Well, also this 150 will be 200, so we have this upper right shift of yd prime equals 200 plus 0.9 times y, and we have y star prime equals y star prime. Well, of course, what you also can do is doing all the calculations again. Just say now yd is 200 plus 0.9 times y, equating this with y, and redo all the calculation. This is totally right to do it. But of course, you can have just also just a look. What have I done before? Nothing really changes, only the number. And then you have directly the new result that new equilibrium income is equal to 2000. Well, if I pose such a question in an exam, then you can redo all the calculation, of course, but you can also more or less in one line give me the new result. But please give me just a hint if you do only one line, what you have thought about. Because sometimes if you take the fast lane, you just miss a factor of 2 or something like this. And then the result is wrong. And if I read in an exam, in a written exam, only a wrong result, what can I do? But if I see, well, you marked me here, something changes, just underline it or give me a hint what you have thought about, and if you then miscalculated at one point anything, then I see, well, you thought in the right way, maybe 1 point less or something, but not 5 points less. Okay? So, determine the expenditure multiplier. So here, let's write this down. WiSe to be complete, 200 plus 0.9 y, yd star prime equals y equals y star equals 2000. the multiplier via the geometrical series or via the analytical calculation. Geometrical series. What do I mean? I want you that you know what happens economically by this argumentation. So what happens if we increase or if we're doubling government expenditure from 51 to 100? This means we have a delta G equals 50, okay? From 50 to 100 is plus 50. So this is then, so to speak, a first impulse in our economy. This is directly adding 50 as new demand. So this translates then in delta Y1 equals also 50. Government directly say we want to buy 450 million new tanks in times of war. So we have directly 50 million euros new demand in our economy. What then happens? We have to buy these new tanks by an enterprise. So this enterprise has an income of 50 million. And then we have the, where is it? Marginal propensity to spend. This enterprise, these households, these individuals behind the enterprise start to spend 90% of their new 50 million. So we have an additional consumption. Let's say this delta C2 equals 0.9 times 50 is 45. But this 45 also enters our demand up here. So this is, so to speak, a second impulse, an implicit impulse in our economy. So this translates then in delta Y2 equals 45. Let's say this enterprise buys for 45 million, or all enterprises buy for 45 million new cars. So we have additional income in the automotive sector of 45. Again, 90% marginal propensity to consume. All these guys, also these guys in the automotive sector start to buy new products with 90% of 45 million. So we have a delta C3 equals 0.9 times 45 is 40.5. And I'm a cyclist, so all these guys now buy cycles for 40.5 million. And so on and so on and so on. So what we then have is delta by 3 equals 1.40.5. We have to add up all these impulses, delta y1 plus delta y2 plus delta y3 and so on. So it is 50 plus 45 plus 40.5. And now we can rewrite these numbers as 50 times 0.9 to the power of 0, 0.9, 0.9 square, plus, and so on. And this here is our geometrical series. And from this geometrical series, hopefully in class 9 or 10 in school, you have shown that this geometrical series converges to 50 times 1 over 1 minus 0.9 is then 500. Heureka, 1500 is 500 less than 2000. Or, in general, from the analytics of our functions, we have y equals c0 plus cy times y plus I plus g. If we solve this in general for y, we obtain y star is c0 plus I plus g over 1 minus cy. And then we can ask what happens to our equilibrium income if we increase government expenditure. And this is nothing else than calculating the derivative of our equilibrium income with respect to the variable government expenditure. So dy star over dg equals 1 over 1 minus cy. And again, we have this factor of 10. Every increase of €1 government expenditure increases our equilibrium income by a factor of 10 if the marginal propensity to spend is 0.9. And the last exercise, where is it? There. Snipping tool, there. So, and now we introduce the interest rate dependence of investment, and of course we introduce our money market. So we are moving now from the Keynesian commodity market to our ISLM model. The first part, so formally the average consumption is falling in with increasing income. Well, let's just skip there. I wanted to make another point. Let's start with number B. Determine IS and LM curve. What do we have to do for the IS curve? Means all IY combinations for commodity market equilibrium. So this just means we take our condition we have here y equals yd. But now we have to insert also the interest rate dependence of our investment. So y equals yd. Again, y is C0 plus CYY plus now I0 plus II times I plus G. Inserting all our numbers, we have we have 5 plus 0.75 y plus 5 minus 100 I plus 5. Adding all our fixed numbers, we obtain 15 plus 0.75 minus 100i. And now you can do it as you like. You can solve these equations for interest rate I or for income y, as you like it. I just solved it for y. Let's do it. So minus 0.7y. Then we obtain 0.25. Y is 15 minus 100i. In order to get rid of the 1/4, multiply this by 4 and we obtain y is 60 minus 400i. And this is the equation for the IS curve. Well, what is LM? All I, Y combinations for money market equilibrium. What was the money market equilibrium? Amount of real money equals money demand. M over P equals L of YI. Inserting our numbers means 50 equals 2y minus 200i. And since we of course afterwards want to calculate the overall equilibrium, in this case, then I also solve this for y. You can of course also solve this for I and then inserting the I in the IS curve. There are many ways to get to the overall equilibrium. So minus 200i and dividing by 2, then we obtain 25 minus 100i equals y. Hopefully I'm right. Plus, of course, sorry. So this is the LM curve. Income at equilibrium. Well, then of course we have to equate LM equals IS. Here we have the IS curve and here we have the LM curve. So 25 plus 100i equals 60 minus 400i, and then we obtain 500i equals 35. Is it still working or? Oh, where is my Zoom meeting. But the recording still works. Okay, great. Is 35, and then we obtain I star is 7%. How do we obtain equilibrium income? Idea? Well, inserting in LM or I or IS, okay? So let's insert this here. 60 minus 400 times 7 over 100. This is 28, so 32. And hopefully this is the same as 25 plus 100 times 7 over 100. Okay, both is 32. So, and now I take red d delta G equals 1. Where does anything changes? Of course, overall we have a change, but what is again the starting point? The starting point is again only here our G. There we have to move, insert plus 1. So this will be a 6. If this is a 6, we have here a 16. If we have here a 16, 4 times 16, we have here a 64. And nothing else we have. Just the IS curve is now IS star 64 minus 400 I equals Y. And again, now we have to equate LM equals IS prime. Okay, you have an idea? Um, yeah, you have already calculated. Now, of course, then we have 64. Then we have what is it here? 64 minus is then 39. Am I right? Yep. This is 39. And then we have here 7.8%. Then we have here 7.8%, 7.8%, and this will be then 32.8. Okay, so I think you're, pardon? Yeah, but I think you had the right idea, right? Yeah. Okay, here we have then 25 plus 100i equals 64 minus 400i. We have I star is 7.8 and y star is prime is 32.8. Well, we shall this compare with the pure commodity market effect. Here we have then delta y, because of an impulse of delta g is 1, moves from 32 to 32.8. So delta y equals 0.8. And this is not really nice, or? Because an increase of delta g of 1 has only an impact of an increase in income of 0.8. So this means delta y over delta g is less than 1, the fiscal multiplier. And this I think I said to you in the lecture, this we did in winter 2008-2009 in the global financial crisis. Then we were asked in the Council of Government of Economic Experts, well, what will happen in our economy if we now make a push via fiscal policy? Is there really then a positive income? And a positive income means, does there comes more out than we put in? So is our fiscal multiplier larger than 1? And we feed it in all the numbers in a multi-sector, multi-equilibrium model, and we came out with a fiscal multiplier of roughly 1.3, 1.4. And then just in December, we started all our fiscal programs. And I think really we were more or less the first institution which really came out with a hard number. All the other institutions, well, they said, well, we don't really know if the fiscal multiplier is larger than 1. And in this example here, the fiscal multiplier would be less than 1. And if we compare this with a fiscal multiplier in the pure commodity market, of course, delta y over delta g would be 1 over 1 minus cy would be 4. But what we have here is the negative dependence of investment. So our push, increasing demand via government expenditure, increases interest rates. And since we have here this dependence minus 100 I means that this increase of the interest rate really dampens the private investment I, and this over dampens the fiscal impulse, the initial fiscal impulse of delta G equals 1. So we obtain in this parameter setting only a fiscal multiplier less than 1. And of course, for practical issues, this is the thing you have to do. You cannot only argue, well, in general, we have then more consumption and so on, and let's do it. You have, of course, to estimate the parameters in your economy. And then money. I think this we will also get. What happens if delta M equals 10. Well, of course, then we have to look at the LM curve because this number increases by 10. Since we assumed, I think, P equals 1, this means also that real amount of money increases also by 10. So this will be then a 60 plus delta M equals 10. If this is 60, we have here a 30. So delta M equals 10 means LM prime is 30 plus 100. I equals Y, and then LM prime equals IS is 30 plus 100. I equals, and now the old one, of course, is then 60 minus 400. I see here, this has also to be a 64. And then, of course, we would have here a 30. We would have then here 30. So we would have here then 6%. This would be then a 30 in the monetary case. And 6%, this would be a 30. 60 minus 6 times 400 over 100 is 24. So then we have here 36. And of course, this would also be a 6. And 30 plus 6 is also 36. So if you solve this, we obtain I star double prime equals 6% and Y star double prime equals 36. Well, let's think, because we have the talk in 15 minutes. What else should we do? Well, I don't know how long is the meeting on Thursday. So maybe I will launch a Zoom meeting afterwards on Thursday. Or do you have time? I think the meeting will not last more than 2 hours. Do you have time at then 12 o'clock on Thursday? Just via Zoom. Okay. Because I also want to do just one recapitulation of the total lecture, that you know what I'm maybe asking in the exam and so. Yes, of course, of course. Yeah? Okay, because now I have to go in the large lecture hall.